So in this video, we're just going to kind of overview nuclear chemistry. This is a long video, free to skip it. It's just kind of more of a historical context. So when I start teaching Chem 1, I always start out talking about the alchemists and how the alchemists were really out there to convert things to gold. And it's funny because that's where chemistry started. They did a bunch of this quackery and they went to chemistry, and then in the past century, we've gone back to this idea of transmutation, converting elements from one form to another. And we have particle accelerators for this. So when you look at the periodic table and you see the back end of the bottom of the periodic table, and you see all these ones with parentheses around their atomic numbers, and you see weird names for them like cobernicium or you'll have some quantium. These are actually synthetic elements. So what we've done is we've taken two nuclei, we've crashed them together, fused them by fusion, and created new elements. Now, nuclear chemistry is pretty limited at the Chem 1 level, and to be honest with you, it's pretty limited unless you really decide to specialize in it. And the reason is the nucleus is not that well understood, and this is a full disclosure for you. We don't actually know what goes on in the nucleus. It's easy to pull an electron off. We have cathode ray televisions, cathode ray computer screens. Pulling an electron off and studying it is very easy. But to take a nucleus and tweeze it apart takes the energy of a fission reactor, and we just don't have the ability to practically do that on a benchtop. And so because of this, a lot of the nucleus remains a mystery to us. One of the few things we understand about the nucleus is that, like electrons, protons and neutrons seem to have orbitals. But these aren't orbitals in the atomic orbital sense, these are orbitals in terms of the nuclear orbitals. And the protons and neutrons will occupy energy levels within the nucleus. So it's basically acting like an electron, but confined to a really small space with a really high mass. But we haven't done a very good job of mapping it. And the big reason we haven't done a good job of mapping it and figuring out all the orbital configurations of the nucleus is that it just takes a ton of energy. Gamma rays are not something, and the gamma rays are the energy you need to probe this. Gamma rays are so high in energy we can't produce them here on Earth without detonating a nuclear bomb. That's just the type of energy it takes. So in the videos that follow, it's very simplified, so you may look at it and go, this is pretty easy. It is. And the reason is that we just really don't have that great an understanding of how the nucleus works. Now I'm sure people will comment and say we know a lot about it. Yeah, we kind of do, depending on when you go view this video. But to be truthfully and full disclosure with you, there is a lot about the nucleus we just simply don't understand. So this is going to be a very scant chapter, and it's going to be a very superficial chapter.